Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 10.7 entitled Factoring Special Products. Now, we've talked about the special products before. We've talked about the difference of two squares and the perfect square trinomial. So now we're just going to work backwards, where instead of multiplying them out, we're going to look at the multiplied answer and then work backwards to factor them. And then we'll also solve some more quadratic equations. Now, when we looked at these in section 10.5, we found their products. So this is where we did our foiling, or our double distribution. So we took the x times x, and we got x squared. The x times the negative 5 was minus 5x. And then the 5 times the x was the plus 5x. And the 5 times the negative 5 was minus 25. And then we said that these middle terms, if we combined them, since they were like terms, they would cancel. So we got x squared minus 25. Okay, and that is our difference of two squares. Now, if you notice, in the parentheses originally, we had the exact same terms except there was a plus or a subtraction in one of the parentheses or the other. Anytime that happens, we're going to end up with a difference of two squares. So the same is true when we go backwards. If we start with a difference of two squares and we factor it, we're going to end up with the exact same terms, except one will be positive and one will be negative. So if we know that rule, then we can say, if I have a difference of two squares, I can just factor it right into that pattern. Then we also had our perfect square trinomials, and here we had to rewrite them again. X plus 7 times x plus 7. Remember, we talked about how a common mistake is that students just want to distribute the 2 and square the x and square the 7. But that's not accurate because we missed that middle term then. We have to do our x squared and plus 7x, and then another plus 7x, and then 7 times 7 is 49. So we missed that middle term of the 14x if we just try to distribute that squared to the x and the 7. Now notice that we started with 7 in the parentheses and our middle term is double that. And then the 7 squared is the 49. So we get a trinomial that ends in a perfect square. That's why we call this a perfect square trinomial. And it works the same if we have subtraction as well. We'd have to rewrite it x minus 4 times x minus 4. And then we have to FOIL. So we'll have x times x times negative 4, and then another negative 4x, and then a 16. So again, originally I started with negative 4 in the parentheses. Now I have negative 8x. So it's double that middle term. And then the 4 squared is the 16. So again, it's a trinomial that ends in a perfect square. That's why we call it a perfect square trinomial. And again, these patterns work forwards and backwards. So if I see that I have a trinomial that ends in a perfect square, and the middle term is double the square root of that perfect square, then I'm going to be dealing with a perfect square trinomial. So if I can recognize that, I can just go right to this factored form. Now that's probably a little bit more difficult to see. So we can still use our taking out a GCF, and we can use our guess and check, we can use our box method, we can still use all of those strategies to help us factor these two patterns or three patterns, depending on how you want to think about it. Now again, for notes, I'm going to focus mostly on the guess and check method. And if you want to see the box method or the triangle method or the crisscross method, we can show you that in class. Now for example 1, I have 5 little parts here. And we want to factor the expression if possible. If not, if we can't factor it, If it has no factors, then we'll call it prime. So you're going to see that more in your homework tonight as well, where they're going to really make you think as to whether or not can you factor this expression that they're giving you. So the expressions we're going to focus on, though, are going to be either the difference of two squares or the perfect square trinomials. So for part A, I have two terms. So since I have two terms, I want to see if it's a difference of two squares. Now, it is a difference because it's subtraction, and x is squared, and 64 is a perfect square, so this will be a difference of two squares. So I'll need an x, and the square root of 64 is 8, so I need to make one positive and one negative. Now that's really easy because I know it's a difference of two squares, and I know the pattern that follows when I factor it. If you need to check your work, you can. Multiply it out where you get x squared minus 8x plus 8x minus 64. And then those middle terms will cancel, so you end up with the x squared minus 64. Or you could still do guess and check. You could say, okay, my lead coefficient is a 1, so I need the factors of 1 and then I need the set factors of 64. Now, the other way to write this is x squared plus 0x minus 64. So then when you're trying to find your factors of 64 that add up to the middle term, you know that they have to add up to 0. So the only way you can get to 0 is if you have 8 and 1 is positive and 1 is negative. So there are several different correct ways to think through these problems. Okay, now part B again only has two terms, so it's probably going to be a difference of two squares. But if I look, it's not a difference, it's a sum. Now, x is squared and 25 is squared. Because this isn't a difference, I can't factor it. There's no such thing as a sum of two squares. So this one is not factorable. This one we'll just write prime. Now for part C, I don't have two terms anymore, I have three terms. So this is probably going to be one of my perfect square trinomials. So I want to look at my numbers. I have 9. It ends in a perfect square, so that's good. The square root of 9 is 3, and 3 times 2 is 6. Okay, so it looks like it's following that pattern, but take a look at my signs here. I have a negative and a negative. And if I go back for just a moment to our patterns here, I didn't have a negative and a negative in either of my patterns. I had a plus and a minus and a plus. So because I don't have those signs that are either plus plus or minus plus, then this one is not going to be factorable. This one will also be prime. Okay, let's try part D. Okay, I have three terms, so we're going to see if it's a perfect square trinomial. My first term is, I'm sorry, my last term is a perfect square. I also have a first term that's a perfect square. And then let's see, the square root of my last term would be 4. Square root of my first term would be 3. 4 times 3 is 12, and then double 12 is 24. Okay, so it seems like we're following our pattern. I have the right signs with the minus and the plus. So it looks like this is going to be a perfect square trinomial that we'll be able to factor. Okay. Now again, if you are struggling with recognizing these patterns, then just treat this like we did in the previous section where you have a lead coefficient and you need the factors of 9 and 16. So the factors of 9 are going to be 3 and 3, and the factors of 16 are going to be 4 and 4. Now there are other factors of 9. There's 1 and 9, and there's other factors of 16, like 1 and 16 and 2 and 8. But when both of them are perfect squares, most of the time you're going to use those perfect squares as your factors. And then if you check your outers, you'll get 12, and your inners will also get you 12. And 12 and 12 will get you to a -4, I'm sorry, -24 if you make both of them negative. So you have minus and minus. Now, when your parentheses match, when they're exactly the same, we have to go one step further and we have to rewrite this as 3c minus 4 squared. Now, if you didn't do that, if you just left it 3c minus 4 times 3c minus 4, technically that's correct. These are the exact same thing. It's just the answer in the box here is more condensed. It's more mathematically precise. Okay, but if you forget to do it, we're not going to count it wrong because you did the hard work and you did factor it correctly. Okay. Now part E, again, it's a trinomial. So I'm going to see if I have another perfect square trinomial. My last term's a 2 and my first term's an 18. Those aren't perfect squares. But if I look at my numbers, 18 and 12 and 2, hopefully you're noticing that they're all even. And we could take out a 2 from every single one of them. So here we could take out a GCF. So if I take out that 2, then I have 9x squared plus 6x plus 1. Okay, so now that everything's a little bit smaller, let's look at it again. I have a 9, which is a perfect square. I have a 1, which is a perfect square. Square root of 1 is 1, square root of 9 is 3. 3 times 1 is 3, and double that is 6. All right. And I have my plus plus, which is what I need for one of my perfect square trinomial options. So here, I'll be able to factor this. So again, I'll need the factors of 9, so that's going to be 3x and 3x. And the factors of 1, it's going to be 1 and 1. Now if I check my outers, I get a 3. My inners, I get a 3. And 3 and 3 will get me to a 6 if I make them both positive. And then I still need to bring down that 2 in the front there. So the stuff in the parentheses matches, so I'm going to rewrite this. Leave the 2 in front, but then I'll rewrite the parentheses, 3x plus 1 squared. Okay, so like I said, most of your homework is going to be dealing with a difference of two squares or that perfect square trinomial, even here when we're dealing with equations. So again, we're going to solve these equations by factoring. Now, I want to make sure it's all set equal to 0. And for part A here, it is all set equal to 0, but it's not in descending order. So I'm going to rewrite it just a little bit. So I have 18x squared minus 32. Now, I only have 2 terms, so this is probably going to be a difference of 2 squares. But if I look at 18 and 32, I could take out a greatest common factor. I could take out a 2 from each of those because they're even. And then that would leave me with 9x squared minus 16. Now hopefully it's more obvious now that 9 is a perfect square and 16 is a perfect square. And they're being subtracted, so this is definitely going to be a difference of 2 squares. So I'll have 3x and 3x and a 4 and a 4. And remember, for the perfect squares, I need one to be plus and one to be minus. Now, if I'm solving this, I have to set each little greatest common factor or group of parentheses equal to 0. So I'd have to set 2 equal to 0, and the 3x plus 4 equal to 0, and the other 3x plus, minus 4. Let me erase that. Equal to 0. Now, this 2 equals 0, that doesn't make any sense, so I'm just going to kind of ignore him for now. That's not a true statement. But here, this is a two-step equation that I can solve. So I'll subtract the 4 over, and then I'll divide by 3. So I get negative 4/3. Again, that's okay to leave it as an improper fraction. Here I will add the 4 over and divide by 3. So now I get 4/3. Okay, so again, remember, this is still a quadratic. It's still a parabola. So if we graphed this, these would be the locations on the x-axis where the parabola would cross. So negative 1 and 1/3, which is what negative 4/3 is, or 1 and 1/3, would be really hard to read off a graph. So it's a good thing that we are able to solve these algebraically, get our precise fractional answers. Okay, now for part B, our last one here. It's all set equal to 0. It's all in descending order. That's good. And hopefully when you're looking at this, you see the 4 and the 40 and the 100, and you realize that you could take out a 4 from every term as the greatest common factor. So that'll leave us with b squared minus 10b plus 25. Now I'm just going to kind of ignore the 4 for now that I took him out. I'm going to focus on what's in parentheses. And that's a trinomial, so it's probably going to be a perfect square trinomial. I don't have a lead coefficient, so that's good. It's easier. 25 is a perfect square. That's good. Square root of 25 is 5, and double that is 10. Okay, so it's following that pattern for a perfect square trinomial. I also have the right signs. I have the minus and then the plus. So this is definitely going to be factorable with our perfect square trinomial pattern. So the factors of b squared are b and b. Factors of 25 are 5 and 5. Now to get the 5's to add up to a negative 10, I need them both to be negative. So again, now that I have this factored, I would set each part equal to 0. Remember the 4 equals 0, that doesn't make any sense, so we just kind of ignore that. And then I have b minus 5 equals 0 and b minus 5 equals 0. So they're the exact same thing. So I wouldn't necessarily have to even write 2 equations. I could just write the 1 equation and solve it, because here I'm really only going to get one answer. So this would be a parabola that just touched the x-axis at 5. Okay. It doesn't hurt you to write this other equation though. But even if you notice that, hey, those are the exact same thing, I don't have to write it twice, I can just write it once, that's okay. So if you left off this other equation over here, that would be okay. That wouldn't be wrong. All right, so try to recognize these patterns. Try to focus on just difference of two squares or perfect square trinomial. Worst case scenario though, just factor it with guess and check or with the box method like we've been doing. And same thing for the equations, factor them first and then set all the little parts equal to 0. Show your work on those and remember to look for a GCF. Take out that greatest common factor first if you have one, because it'll make your numbers smaller and will make the factoring easier. So show your work, and if you have any questions, come on in and see us before school.